This screencast will talk about how we classify bones. So we classify bones based on their shape, and then based on their shape, they have differing functions. Our classifications of bones include long bones, short bones, sesamoid bones, flat bones, and irregular bones. So we'll begin with long bones. Long bones are longer than they are wide, so they're shaped like a cylinder. Because they're shaped like a cylinder, they're really good for movement. They're light and they're hollow, and so they are able to move easily by acting as levers. They also provide some support, for example, in the lower body, lower half of the body, the lower limb. So you have your bones of your legs do support the rest of your body. So again, we're talking about movement and support. They're not the most stable group of bones because they have a lot of mobility. And stability and mobility are, generally speaking, opposites. You sacrifice one for the other. So examples of long bones include the bones of the legs, the femur, the tibia, and the fibula, the bones of the arms, including the humerus, the ulna, and the radius, your fingers and toes, also called your phalanges, the bones of the hands and the feet, so the metacarpals and the metatarsals, and your clavicle or collarbone. And so you can see here that some of these long bones are very large. Other long bones are small. And even if they're small, they can still be long bones if they're longer than they are wide. So you can see even these phalanges, the little tiny toe bones, are longer than they are wide, and that's what makes them long bones. Our next classification of bone is short bones. Short bones are approximately cube-shaped. They're not perfect cubes, but they're approximately cube-shaped. Their length is approximately equal to their width, which is approximately equal to their thickness. Here we have a lot of stability with very little motion. Examples of short bones include the carpals in your wrist and the tarsals in your ankle. And so if you look at these parts of your body and you try to move these parts of your body independently of the nearby parts of your body, you can't really do it. So for example, in your wrist, so this part of your wrist, your anatomical wrist, is actually what we would think of as the start of your hand. So if you bend your wrist, where you're actually bending is right in here. So when you flex your wrist, you're flexing this joint here. Now, if you try to move a little more distally and actually move the individual bones at the start of your hand, which is actually your wrist, you can't really move these bones. Certainly not just, out of contracting muscles. You can sort of move them a tiny little bit with your other hand, but you can't just move them. And that's because they're very, very stable. Next, we have our sesamoid bones. Sesamoid bones are small and round, and they're embedded in tendons. Their location within tendons is very, very important because they're going to both protect the tendon and increase mechanical advantage. So they're going to make you be able to do more work with less force input. So when talking about protecting tendons, it changes the force and the pressure and also prevents rubbing. So for example, when we look at our sesamoid bones, our biggest and most well-known sesamoid bone is your patella, which is your kneecap. And so if you look here, you can see that the patella is very mobile because it's not actually attached to any other bones. It just sits within your quadriceps tendon. So here you have your patella, and this is going to glide on the end of your femur when you flex and extend your knee. It's going to protect this tendon from rubbing against the bone, and it's also going to change the angle of pull. So it's not just one big long tendon pulling, but instead it's more like two short tendons pulling at different angles. And so that gives you a mechanical advantage as well as protects the tendon. You also have sesamoid bones at the base of your big toe and the base of your thumb. You don't really notice them unless they get injured. So they can either get inflamed or they can crack. So you can see here that's a fractured sesamoid bone. Next we have flat bones. Flat bones are flat. They are thin and they're curved. They protect internal organs, so you're going to find these flat bones surrounding internal organs, and they also provide an attachment point for muscles. Now, of course, all bones, except for your ossicles in your ear, do provide attachment points for muscles. However, because they have so much surface area, there's a lot of attachment available for muscles. So if we look at examples of flat bones, we see that we have the sternum, the ribs, the pelvic bones, the scapulae, and the cranial bones of your skull. When we're talking about your skull, we break it into two areas. Here, what's colored in is your cranium, and then you have your face. And so we're talking about the cranial bones that are protecting your brain. Again, you have flat bones that are really good for protection and can kind of wrap around and encase the organs that are within their they form the cavity, so they can really protect those organs that way. And because they're so flat and have great surface area, they're able to be an attachment point for a lot of different muscles. Finally, we have irregular bones. Irregular bones have a complex shape. They've got lots of things kind of sticking off, and that's because they're a great attachment point, again, for muscles and ligaments. Additionally, they protect internal organs. So examples of irregular bones are your vertebrae and the bones of your face. So here you can see they're all kind of weird, different shapes. There are lots of muscles within your face that are attached to these bones, and then within your vertebrae you can see this is almost like a short bone, but then it's got all this stuff on the back, and so it is an irregular bone. So those are your 5 classifications of bones based on their shape: long bones, short bones, sesamoid bones, flat bones, and irregular bones. And once again, their shape is going to help determine their